It's great to see you all after too many years. I will apologize in advance for sitting during this presentation between being a little nervous about doing a presentation for the first time in a while and a slight heart condition. If I stand for too long, my heart rate goes up and I begin to sweat profusely, and I guarantee that will be an unpleasant experience for us all. So to save you that, I'll be sitting through the presentation. So today we're going to be talking about simplifying secure, scalable web services. And I almost dropped out the web from the name because I really like alliteration. My name, Brian Becker, is alliterative. So simplifying secure, scalable services just had a nice ring to it. On Sunday, we conducted 2 workshops, one in the morning and one in the afternoon regarding web services. And we gave a quick introduction to Jarvis, which is our framework for providing RESTful and JSON-based web services. We talked about Docker and running the services in a Docker image. We looked at Docker Compose to describe a collection of images that comprise a service. And then we moved that service out onto the web in the cloud using Amazon Web Services. And then we learned how to scale the system so that it's fine when you're running a single service, you've got a couple of users, but when you have 10,000 or 100,000 users, you might want to scale it up and not have a single process trying to handle all that traffic. And then we learned how to assign your own domain names so that you aren't using a really cumbersome Amazon assigned domain. And finally, we learned to secure the service. So a recap of Sunday, the first workshop was building web services with Jarvis. And again, we learned a little bit about Jarvis. We learned about the important configuration settings, debugging, and maintaining state. And then we ran out of time and didn't get a chance to introduce just barely 3 versions of a Phonebook application that we implemented as a web service. And then in the afternoon, Morton and I gave a workshop on deploying services, and we started with that same Phonebook application. And by the end of the workshop, we're pleased to say that about 70% of the participants actually had a load-balanced, scaled web service running on Amazon, and that, if they could make it through that gauntlet, we consider it a success. And then we were able to demonstrate running it securely. You'd have to get a certificate and have your own domain name. So Morton had done that, and we were able to demonstrate running the service securely. So we had a plan, right, which was to start with an application, use Jarvis to turn it into a web service, then run the web service in a Docker container locally, and then split it into 2 tiers, right, a front end and back end. And the front end would handle all of the user requests, and for those requests that were read-only from the database, it would just go directly to the database. But anything that required writing to the database, we single-threaded through a single back-end service so that we didn't run into problems with potential file holds, conflicts running in different processes. And then we ran that new service in the cloud on AWS. We scaled up the service by running multiple copies of the front end, and then we added a load balancer to distribute the requests among the front ends. And then finally secure the service by running HTTPS. So that was the plan. And so in the beginning, there was an app, okay? And the app, doesn't matter really what it is, and it might be talking to some kind of a database. It might be a relational database manager. It could be component files. It could be, text files or whatever, FlipDB. And so the idea was, okay, let's turn that app into a web service using Jarvis. And so Jarvis stands for JSON and REST services. And we kind of had to permute the VICE to VIS for Jarvis, and so that's how we came up with that name. And again, it's a web service framework to build REST or JSON-based services. If you don't know what the difference between those is, come see me, I'll tell you. But using the JSON paradigm, your APL functions are the endpoints of the service. So if you have a monadic result-returning APL function, you can expose that as an endpoint of your service very, very easily. So the request payload is passed to your function as an APL array, okay? And your function returns an APL array. So you don't need to know anything about JSON. All you need to know is about APL data, and hopefully most of you do. And Jarvis handles all of the conversion between JSON and APL and back again. So you don't need to know anything about web services. You don't need to know anything about JSON. You don't need to know anything about HTTP. You can have a web service up and running just using the APL you know and hopefully love. So I was going to do a demonstration of Jarvis in action, and I'll do that if we have time at the end. But when I showed Morton my slide deck, he said, "Ooh, you've got a lot there." And so rather than try and cram and speed through the rest of the presentation, we'll save the Jarvis demonstration for last if we get a chance. So this is the get users endpoint from our Phonebook application, and it's being executed from a web browser, right? Using a JavaScript client that's in, Jarvis has a built-in test page. So you can test your endpoint. So this is the endpoint, which is just an APL function in my workspace called get users. It takes, actually it takes any argument, so I just give it an empty JavaScript or JSON object here. And then when I click send, I get some JSON back. And again, your APL didn't need to know anything about the JSON representation. It saw an empty namespace as its argument, and it returned a namespace as its result. And Jarvis handled all the conversion back and forth. So this means that you can have any client anywhere, any platform that's capable of issuing HTTP requests, and that's basically everything, can interact with your web service. And so the client, whoever's developing the client, doesn't need to know anything about APL, nor even the fact that your service is running APL. And so here's an example of, from the command line using the curl command, to issue a request to that same web service, and there's the result. And similarly, you can even call the web service from APL. We have a utility called HTTP command, and it, you can see that it's calling the same endpoint and getting the same data back. So that's kind of cool. So the next thing is, okay, now we have a running web service. Let's try and run it in a container. And what you need, well, we use Docker for our container service, and a Docker file kind of describes how to build a container. So what we're saying here is from Ubuntu, we're starting with a version of Ubuntu, we're going to copy in the Dyalog installation file. We're also going to copy in the code that's our application, and let me actually skip forward here. And then we're going to say, okay, when you build this package, we're going to install Dyalog APL, we're going to clone the Jarvis repository, then we're going to set up a couple of environment variables, and then all we do is we start Dyalog on this workspace, and there's your web service. And if you don't want to write all of that, there are public Docker containers, and Dyalog provides a few of them. But basically, Docker Hub is a public repository of Docker containers, and it's to Docker as GitHub is to Git. Okay, and so it contains container images. You have free, unlimited public containers. You can put as many out there as you want, and you also have one private, and that's free. You can have a pay subscription to Docker Hub and get more private repositories or whatever, but for most of us, unless we're concerned about hiding or not making our containers public, the free tier is perfectly adequate. And Dyalog has built several public containers, and they're available on Docker Hub. There's Dyalog, which is just Dyalog APL. There's Dyalog MyServer, which is Dyalog plus MyServer. Dyalog Jupyter, which has the Jupyter Notebook framework, and then Dyalog Jarvis. And so we use the Dyalog Jarvis container as our starting point. And you can see here I've typed in Docker run some stuff. We'll go over that later. And you can see a familiar Dyalog banner starting up. And at that point, our web service is available, and you can connect to it with a client, any client. So breaking down that line, the first thing says Docker run. Okay, that makes sense. Then we're going to map our local port 8080 to the container port 8080. The Dyalog Jarvis container runs on port 8080 internally by default. but you can expose whatever port you want here. So if I wanted it to run on port 1234, I'd put 1234 there. Then you map a host folder on your system to the /app in the container. Again, in the Dyalog Jarvis container, /app is where it expects to find your application code. And so we map my local folder sa2 v3 to /app. And then I set a configuration file, which is a Jarvis configuration, or I set a Jarvis configuration setting to tell it where my configuration for the service is, the internal things that Jarvis needs to know. And then finally, we use the Dyalog Jarvis public container. And it's really that easy. So in our workshop, we actually created our own Docker file. And we basically said from Dyalog Jarvis latest, which is the latest version of the Dyalog Jarvis container out on Docker Hub. So that's our starting point. We're going to add in the code found in the app folder, local, relative to where the Docker file is, and we're going to map that to app. And then we're also going to pull in HTTP command for our service. And then to build it and tag it as Phonebook, so now we can refer to it as Phonebook from now on, we just say a Docker build with a tag, Phonebook, and the dot means do it here in this current folder. So then when we split it into the front and back ends, I described how the front end does all the read operations directly, but it relays write operations through the back end, and which goes and writes to the database. So Docker Compose describes a collection of containers that operate together as a service. And it, like I just said, but it also creates a virtual IP network that connects the images together so that they can refer to each other by name. And I was gobsmacked, is that the right British term? When I asked Morton when I was building the front and back ends, I said, well, how do I know what the IP address of the back end is? And Morton says, well, you just call it back end, and it works. Images also support the replication of images and load balancing, and we'll talk about that in a little bit. So a Docker Compose file, so we're defining two services here, front end and back end. And then we're using the same Phonebook image. We're using the same permanent storage. We're using different Jarvis configurations, right? One is for the front end and one is for the back end. So this basically loads up the different APL code that does the front end operations and the back end operations. And the front end actually talks to the back end using HTTP commands. So it just sends off a request and processes the result. But then we have, on the front end, the clients access the service via port 8080. And then we also defined, for debugging purposes, a zero footprint ride, which is on port 8088. And so the Dyalog Jarvis thread debug gives us the ability to more easily debug a web service, and then we tell the APL to serve up the zero footprint ride site on port 8088. And then you'll see we're also doing similar things. You notice that we're not exposing a port directly to the outside world. So the front end, because it's on the same network or virtual network as the back end, can talk to the back end on port 8081, but it's not exposed here to the public. And then we also have a zero footprint ride attached to the back end, so we can do debugging on either of the images or either of the containers. And then finally, if you notice, we've got this thing here that says restart always. So if for some reason the back end crashes, Docker will bring it up automatically, which is kind of cool. Again, that's a lot of stuff that we've had to write in APL ourselves, and it's a real pain in the, well, you pick the part of the anatomy that you want to describe, but it's, this really makes it that easy. So if you want to run that service locally, you basically do a Docker compose, give it the Docker file, and then up says run it. And yeah, it really is that easy. Every time I use Docker, I just shake my head and say it can't be that easy, but it is. So now we're going to move that service we've defined into the cloud. And to do that, we're going to use Amazon Web Services. The first thing to do is acquire an AWS account. They have a free tier, so it doesn't cost you anything at the outset. You provide it with credit card information anyhow, so in case you do start spending resources. And the cost to experiment and do development is pretty minimal. So far, I've used 9 cents, and the projection for this month is 14 cents. So Morton's is a little more expensive. I think his cost may cap out at $20 this month, but he's been using it far more intensely than I have. So Amazon Web Services. If you look at the services provided by Amazon Web Services, you'll find, well, at least I did, that there's just a large number of services with similar sounding names, and to try and figure out which ones to pick out of this menu, right, to build your service is a bit of a daunting challenge, at least it was for me. So fortunately, Morton, with some assistance from Google, and Norbert, we can't thank you enough for your help, and Björn, we worked out the right combination to get our services running. So the first thing you do is you create an IAM user, and then you're going to get some, tell it what credential type you want. You're going to attach some policies. It's going to give you some credentials that you download, and you need to download and save those someplace because you'll be using them later. Then you install the Amazon Web Service command line interface, and to find out how to do that, just Google install AWS CLI. You download it for your appropriate platform, Windows, Mac, Linux, doesn't matter. And then you configure it to use those IAM credentials. So then you're going to be using the Amazon Elastic container services. And Docker Compose can talk to that, can interact with that directly. So you're going to create a Docker context for ECS. And again, it's that easy. Then you're going to switch to the ECS context, right? And finally, you're going to upload your service to the Elastic Container Repository or registry. And so since we already have an AWS user ID, we'll go ahead and move it to there. You could also put it up on Docker Hub, but again, since we're using AWS, we've got a user ID, we put it in ECR. And upload the image. You need to log onto the ECR server using your credentials, and then tag the local Phonebook image on the ECR server as you give it your user ID, and this is why you need to capture some of those credentials, and then you push it out to Amazon Web Services. I realize I'm going fast here, but it's also a lot of material. Or you can just edit and run the push.bat file that was provided in the workshop materials. Again, thank you to Morton for making it life easier for us all. And so this is the Docker Compose for AWS. And there are a couple of things that are different. First of all, we stripped out all of the RIDE stuff for debugging, because really you don't want to expose public ports to your to the internals of your web service on AWS. That kind of makes sense. And we had to add a protocol for the port. We're telling it that we're running HTTP. And what else? And then we had to add a volume so that there would be permanent storage out on AWS for our database. And the database we happened to use was just some JSON files. A real application would probably use a relational database manager or something like FlipDB or maybe component files. But really, it's it's essentially the same compose file that we used for our local service. We just had to add a couple of things to run it on AWS. So now, once we've got it up on AWS, we want to scale it up and have multiple front ends so we can handle more requests at a time. But again, we're still having a single back end to handle the write operations. So to scale up the front end, okay, let's say you want 2 copies of the front end. Well, yeah, again, it's that easy. Docker just, I should send them money because they make life so much easier. And then the really cool thing is you can change the scaling while the service is running. So if you need to bring up 2 or 3 more front ends, you just set the scaling factor accordingly and it does it. So now, once we've got our multiple front ends running, we're going to need some sort of a load balancer so that when requests come in, the load balancer can determine, okay, which front end to send it to based on some criteria, load or whatever. And to make a load balancer, now this part is a bit complicated. First of all, you're going to create an AWS security group. And then you're going to add ingress ports who you want your client to attach to. And then finally, you're going to create the load balancer itself. And again, fortunately, Morten has written a make load balancer function that does all of this for you. So we've tried to take the kind of rough bits in the process and smooth them out a bit. We can probably smooth them out a bit more, and I expect we'll do so as we gain more experience. So all you need to do then is to add a setting in the Docker compose file to specify the load balancer, and it's done. So now we have a load balanced application web service running on the cloud. So to take ownership of it, you're going to use your own domain name. Now Amazon, by default, is going to give you a name like this. Okay, so if you want to type that in every time you want to access the service or have your clients, if you're particularly sadistic, and you want to make your clients type a lot, give them this to access the service, but it would be nice if you could use your own domain name. So if you register your own domain with an ISP that allows you to do redirection, you can have a name more to your liking. And in this case, Morten wrote, registered a domain, and his service is phonebook.kromberg.dk. And hopefully if it's up, yes it is, we'll show you that in a second. And you can use almost any domain registry system. So Morten used one.com to get his domain name. I happen to use GoDaddy. And so now, if you want to secure it, right, so that any traffic that's sent over, to and from the web service is encrypted, and so you're going to want to run HTTPS. And to do that, you're going to need to get a certificate. And for our purposes, we used Amazon Web Services Certificate Manager. And it has a couple of simple steps so that you can verify that you actually own the domain that you're requesting a certificate for. And so you go from the EC2 menu to the load balancers menu, you add a listener on port 443, and you're good to go. So, in summary, well, we learned a lot in preparing these workshops. Morten probably learned a lot more than I am because he did the heavy lifting on the web services, or on the cloud workshop. And we expect to learn more. And the question is, well, have we simplified the process? And I think so, because Jarvis really makes it easy for you to turn your APL code into a web service. And Docker is almost ridiculously easy to define containers. And again, I pinch myself every time I use it. And Amazon Web Services can be slightly daunting, but if you know what to use, it's actually pretty straightforward. And fortunately, in the workshop materials, we've shown you a path on how to get there. So what we plan to do in the near future, well, first of all, we're going to put updated workshop materials. We need to retake some screenshots that were done at an earlier point in the development of the workshop. We want to update them to its current state. And so we'll post those materials probably sometime next week. It might be earlier, but this is a busy week for us, so. For Jarvis, I expect to complete the documentation in November, and if you look at the new HTTP command documentation, I'm really proud of that, and I plan to release something of similar quality for Jarvis. And we're going to provide more training materials, samples, templates, and we plan on doing a series of webcasts. Rich Park here keeps nagging me about getting going on that, but we'll do a series of 5 or 10 minute webcasts that talk about individual components or steps in using Jarvis. And again, we plan to do a webcast series that breaks down the workshops into more bite-sized chunks. We'll focus on probably each of the slides that you've seen here to show you how to do those steps. And we used Amazon Web Services for our workshop. There are lots of other services that support containers. And there's Azure, there's Google Web, I forget what they call it, but Google has a web cloud service. IBM has a cloud service. And we may publish similar guides for other services, particularly if you ask for it, right? If we're stuck with nothing to do, we'll do it, for the fun of it. But if there's a service that you want us to publish a framework for, we can do that. And that's it. How are we doing on time, Andy? Am I out? I have 3 minutes. Oh, how about demo? How about a quick demo of Jarvis? All right. So I need to make the font, I know I need to make the font bigger. Sorry about that. This is my my retro color scheme, right? I started when terminals were green. Well, I started with paper terminals. But then when we finally got CRTs, they were green. And so here what I've done is I've loaded Jarvis. I've defined a reshape function or reshape endpoint. I've defined a high endpoint. And I've created a new Jarvis server, and then I'm just going to start it. And it started it up on port 8080. So if I cleverly do that, is it going to, yeah, there we go. So now you can see I've got a high and a reshape endpoint, and now I just need to give it some JSON data. So I'm going to do 2, 3, 4. So this is a integer vector, right? And then I'm going to give it a string, a character vector. And then hopefully if I close it properly. So now reshape, my reshape function is going to give me a syntax error. What did I do wrong here? What's that? Oh, wrong endpoint. Thank you. Yes. Duh. So if I pass this to the reshape function, you'll see that it creates a 2-item vector of vectors, where each vector has 3 items, and each vector in there is a 4-character string. So I've done the 2, 3, 4 reshape of that string. And then similarly, you can pass it things like, you can pass it objects. So if I say name, Morton, and I pass it to the high, it can, it recognizes that as you get a namespace in the APL side, and I just, pulled out the name element of the namespace and used that. And finally, so this is the built-in page that comes with Jarvis. And then, yes, Phonebook.cromberg.dk, did I get that right? :8080, thank you, yes. And it's not HTTPS. And :8080. Ta-da! There's our Phonebook. And just to prove to you that it actually works, we'll use get users and give it a null, and we get the users table. So this is a load-balanced service running out on the cloud that we developed on Sunday, and it works. So thank you.